Hello, my dear students. Today we are going to solve a numerical problem of multicolor bearing. This is the simple numerical problem related to the multicolor bearing. A shaft has a number of collars integral with it. The external diameter of collars is 400 mm and the shaft diameter is 250 mm. If the intensity of pressure is 0.35 Newton per mm square uniform and the coefficient of friction is 0.05, estimate the power absorbed when the shaft runs at 105 rpm carrying a load of 150 kilonewton, and second one is number of collars required. So we have to solve this numerical problem systematically. So first of all, we have to write the given data. So here you can see that the given data, the diameter of the collar is 400. That means D1. That D1 that is equals to 400 mm, and the shaft diameter that is D2. D2 equals to 250 mm, and they are the value of D1 and D2, and R1 and R2 equals to 200 and 125 mm by divided by 2. D1 divided by 2 and D2 divided by 2. So we have the value of R1 and R2. This is the uniform pressure. P is equals to 0.35, and this is the coefficient of friction. Mu is equals to 0.05, and speed 105 rpm, and the load is also given 150 kilonewton, or we can say that 150 into 10 to the power 3 newton, and the estimate or find or determine the power absorbed. So we have to calculate the value of power absorbed first, and second one is number of collars required. So well, power absorbed, P is equals to 2 pi nt upon 60. So from in this equation you can see the value of n is given 105, but we do not have the value of torque T. So we have to calculate the value of frictional torque T is equals to, and T is equals to 2 by 3 mu w r1q minus r2q upon r1 square minus r2 square for uniform pressure theory, because the pressure is uniformly is given in the question. So now we have to substitute the value of mu w and r1 and r2 from the given data. Then we will have the value of T, frictional torque. The total frictional torque T is equals to 1240 Newton meter. So we have to substitute the value of frictional torque in the equation power absorbed. That this one is T. So that means we have to substitute the value of T. T is equals to 1240, and the value of N that is equals to 105. So substitute the value of T, N and pi equals to 3.14. Then we will have the value of power absorbed. So power absorbed P is equals to 13.64 kilowatt. So this is the first answer, and now we have to calculate the number of collars required. So we have already used the one formula, intensity of pressure P is equals to W upon N n pi r1 square minus k r2 square. That it means the intensity of pressure P is equals to load upon number of collars into bearing area of one collar. Here you can see this is the formula. So we know that the load upon number of collars into bearing area of one collar. So now that we have the value of load, that means W. So we can you can write it here, W upon N into pi r1 square minus r2 square. This is the N is equals to number of collars. So we have to calculate the value of N. So this is the second answer. So we have to substitute the value of W, that is W, that is equals to 150 into 10 to the power 3, and P is equals to 0.35 Newton per mm square, and the R1 and R2 is also given. So we have to substitute all the value in this equation, and we will have the value of number of collars N is equals to. So N is equals to 5.6. So now we can say that 5.6, that is equals to 6, because there is no half collars, either 5 or 6. So we can consider the value 5.6, that is called, or we can say that 6. So n is equals to 6, or we can say that number of collars required, that is equals to 6. Thank you.